Hi everyone, Mike again with MEG Motors. We had an interesting opportunity in the shop that came up. We've recently completed work on this 2004 Honda CR125 engine. This is a two-cycle case reed induction two-cycle engine. And while we had this engine here and on the bench and partially open, I thought it'd be a good time to do a video to talk a little bit about two-stroke engines and how they work and how they're able to do in two strokes what it takes a four-stroke engine to do. So let's readjust the camera, and we're going to look at actual parts of the engine while we hand rotate it through a couple of strokes and talk about what's going on in this engine and how it's able to run in two strokes instead of four. All right, so here's our two-stroke engine. When we talk about an engine, when we talk about displacement and size of an engine, we use two measurements. We talk about bore, which is the diameter of the cylinder, and we talk about stroke, which is the distance the piston travels from the top of its stroke to the bottom of its stroke. And so when we talk about a four-stroke engine, it needs four strokes to complete a combustion cycle. So it has two downward strokes and two upward strokes. A two-stroke engine does the same amount of work in two strokes. So a four-stroke engine, the four strokes that it needs are an intake, compression, power, and exhaust. So it has one stroke, a downward stroke, where it will pull in a fresh fuel charge. It'll compress that on the compression stroke when the piston comes back up. Spark plug will fire, the mixture will explode, it'll have a power stroke on the way down. The exhaust valve will open and it'll have an exhaust stroke on the way up to blow the exhaust out of the exhaust system, and then it will start over with another intake, compression, power, and exhaust. A two-cycle engine has to complete the same four functions. It has to also have a way to pull in an intake charge. It has to compress it. It has to have a power stroke where it blows that mixture up, and it has to have an exhaust function where it gets rid of the burnt fuel. And two-stroke does all of that in two strokes. One downward stroke. Every downward stroke is a power stroke on a two-stroke, and every upward stroke is a compression stroke. And so how does it do that? How can it complete all of those functions in just two strokes of the piston? Well, you have to think of a two-stroke engine actually as if it's almost two cylinders, because the area below the piston is every bit as important as the area above the piston. The area below the piston on a four-stroke engine is vented to the atmosphere. It's just a crankcase. On a two-stroke engine, the area below the piston is sealed. There's crankshaft seals that make it airtight. And it's important that it be airtight because the area under the piston is a critical part of how the two-stroke engine works. And so there's the other thing that we have to kind of take care of on a two-stroke engine is we have to have a way to connect the intake stream, whatever that system might be, whether it's an injection or carburetor or whatever it might be. We have to way to connect that to the underside of the engine and prevent any backflow of gases back through. It has to be a one-way system. And there's three main ways that's done on two-stroke engines. There's a piston port method where the piston, actually the skirt of the piston, works as a valve to open and close a port in the cylinder to open the intake system to the crankcase of the engine. We have a rotary valve system, which typically the carburetor is mounted on the side of the engine, and there's a round disc that will have a hole cut in it that will line up with a hole in the cases to control timing and opening of the crankcase to the intake track. Those are were used a lot in the older two-strokes, like in the 70s. I know a lot of Kawasaki's and a lot of the other bikes use the rotary valve, and Sea-Doos, the two-stroke Sea-Doos, use a lot of rotary valve engines as well. This engine uses a reed valve system, and so a reed valve system, so this sits right here, the carburetor would be connected here. So the reed valve system is essentially a one-way valve. These reeds right here will open when there's a demand for air through this intake system. They'll open, but any attempt to flow back through there will cause these to close and close off that intake system. And it's important that whatever the system is that you use, that the engine uses, whether it's reed valves, piston port, or rotary valve, it's important that that functions as well, because if fuel is allowed to flow back out of the carburetor, the engine typically won't run. And so how does that all work together? So let's start with the piston at bottom dead center, assuming that this engine's not running yet. And so as we kick it through the first time, the piston is going to start to rise up in the cylinder. As it rises up in the cylinder, because the area underneath the piston is sealed, crank seals, remember? Crank seals, everything is airtight underneath the piston. As the piston rises up, it creates a vacuum or low pressure in the crankcase, which causes air fuel mixture through whatever it is, carburetor, injector, whatever it is, causes an air fuel mixture to pull in through the intake system and end up underneath the piston as the piston comes to the top of its travel. And so we have a fresh charge of air fuel mixture underneath the piston waiting to be burned. And so as the crankshaft rotates through the next stroke, which is a downward travel of the piston is going to actually compress that mixture underneath the piston. And as it compresses that mixture coming down through the travel, it's going to eventually open transfer ports. And so we have ports, you can kind of see the castings right here. These ports connect the crankcase underneath the piston up through the side of the cylinder to some ports that are in the side of the cylinder. And as the piston travels down past those ports and they open, this mixture that's underneath the piston that's now being compressed is going to flow up through the transfer ports to the top of the piston. And as the piston continues to rotate now, it's going to eventually rise up until it closes those ports off, and it can start to compress that mixture on top of the piston. So as it comes back up through the stroke, it compresses that fresh charge that it just pulled in and gets it ready to ignite for a power stroke. As the piston was coming up compressing that charge, it's pulling a new charge underneath the piston again. So the second cylinder is on an intake stroke, and the first cylinder on top of the piston is on a compression stroke. So now we have a compressed mixture on top of the piston and we have a fresh mixture underneath the piston. We light the spark plug, the mixture explodes, the piston starts to travel down through its bore. Again, as it's coming down now, we're making power. It's going to compress the charge that it just pulled in underneath the piston. And as we come down, again, compresses that mixture again, opens the transfer ports, that flows on top of the piston, and we're ready for another ignition cycle, another power stroke the next time the piston comes up. So that's kind of how the intake track works, right? That's how we can get a fresh charge of fuel on top of the piston every time it goes up to the top, because we first pull it in under the piston, we compress it, we open some ports, let it come on top, and then we're ready to compress it and ignite it and make some power. So the next problem we have, of course, is exhaust. How do we get rid of all of this fuel that we're burning? And so that's where port timing becomes important. And so when we look down in the cylinder, I'm hoping you're going to be able to see all of this. I attempt to put a light in here. Here's our piston. Let's say we're at top dead center. We just exploded a fuel charge, and the piston is going to start down through its stroke. We're making power right now. The first thing that's going to happen is it's going to open this port. This is an exhaust port. This is where the exhaust is connected. So the first thing that happens on the way down is we open this port, an exhaust port, and the exhaust gases begin to flow out through the exhaust system right away. We haven't opened any other ports in the cylinder yet, just the exhaust port. But as the piston comes down a little bit further, this is where we see those transfer ports that we talked about. The transfer ports are these ports here around the side of the cylinder. And so those are the transfer ports, and as those uncover, the exhaust is still open. The exhaust ports are still open, and we have transfer ports open. So we have fresh fuel coming on top of the piston. At the same time, we have exhaust going out of the cylinder. And so that's kind of one of the problems with the two-stroke engine. While they're really great, they're lightweight, they're simple. Obviously, all of this is happening with very few moving parts. There's no camshafts, no valve springs, anything like that. It's all happening with very few moving parts, but it's a little bit inefficient because right now we have fresh air and fuel mixture coming on top of the piston while we have our exhaust port open. So some of that fresh charge is going to go straight out the exhaust port. And some of the exhaust is not going to make it out of the cylinder. So it's not a terribly efficient system for running an engine. But as the piston comes down through its, continues through its stroke, obviously its intake is taking in a fresh charge and it's gotten rid of some exhaust. We're going to come back up and we're going to close all of these ports off, right? And then we're going to be ready to explode whatever we've got on top of the piston. A little bit of mixture, probably some exhaust gases and some fresh fuel, and bam, we get our power and we come back down. And so in a nutshell, that's how a two-cycle engine works. That's how it's able to do in two strokes what it takes a four-stroke engine to do. And it's because a lot of work happens under the piston, and it's because we deal with some inefficiencies. So one of the ways that we overcome some of those inefficiencies, especially with dirt bikes, is we use a tuned exhaust chamber. And the chamber is tuned in such a way that as the piston is coming back up and it closes off those intake ports, the exhaust port is still open for a little bit more travel. There'll be a pressure wave that comes back from the exhaust pipe. It's based on the length of the pipe and the shape and the diameter of the pipe. This pressure wave comes back, will actually push a little bit of what we just let out of the exhaust port back into the cylinder. And as it does, some of that unburnt fuel that we let escape during this mixed exhaust intake stroke will get pushed back into the cylinder, and it'll put some more volume in there as well, which helps with compression. And so we can recover a little bit of what we lost through the inefficiency by using a tuned pipe and pushing some of that back into the chamber and using it on the next combustion cycle. The other thing that we can do to help a two-cycle or a two-stroke engine work more efficiently, make more power, is use a thing called the power valve. And so hopefully you can see the exhaust port right there and see that we can change the height of the port through the use of a power valve. And so the placement of the port in the cylinder on a two-cycle engine is important. Typically a higher port, the higher the ports are, the more it favors the top end power, and the lower the ports are, the more it favors the low end power. And so to kind of get around the inefficiencies of the two-cycle engine and the limited power that's available, we can use a power valve, leave it down at low RPM to help it make power in the bottom end. And then as the RPMs increase, the power valve will move and the exhaust port is effectively raised in the cylinder, which makes more power on the top end. So yeah, so using a pipe and a power valve, we can greatly enhance the power that we get out of, especially these small 125s. They make amazing power for no more displacement than they have. So yeah, so that's how a two-stroke engine. That's how a two-stroke engine works. That's how it's able to do in two strokes what it takes a four-stroke to do. And that's why it's important on a two-stroke engine that the crank seals be in good shape. If your crank seals are bad, when it's doing the intake phase, when the piston's coming up and we're pulling a fresh charge underneath the piston, if the crank seals are bad, it'll pull in just air from the side of the engine, or it can pull in oil on this side. This side is bathed in oil. It can pull in oil on this side, or it can pull in air in this side and contaminate the fresh air fuel mixture that we're trying to get into the engine, and it'll make the engine run really badly. So yeah, so that's how a two-cycle engine works. I hope that explanation helps. If you had any questions about how a two-stroke engine works, I hope you liked the video. If you did, please like and subscribe, And check my playlist. There's other videos out there about small engine repair. And yeah, check back with me from time to time. We'll have more videos out. And thanks for watching, and we'll see you on the next video.